So we have this question with us. I solved it before, but that was the like most optimal approach. I mean, the most brute force solution that I could think of. So right now, I'll try to do it with the brute force as well as the optimal solution. So the question is maximum subarray. So what we need to do is that we have an integer array nums, this one, and we have to find the maximum subarray, and that is basically contiguous. So that means we can't take any element from the middle and arrange it ourselves. The array has to be contiguous. That means 3, 4, 1, 2. We can't take 4, 2, and 5 or 4. I mean, it has to be continuous with the largest sum and written with sum. So here, for example, in example 3, suppose this is the array. So right now we can see that 5, 4, 7, and 8 are the positive ones. So they can easily give me 24 as the sum. I can't ignore this one because again it's a continuous one. So yeah, it becomes 23. So that's how I have to take the maximum subarray. And now the thing is that if the array is having one element, that's the only one. So let's try for the most like brute force approach that can be having a for loop in which we can start from 0, we can go till nums dot length, and we can have I plus plus. And then, so we can have all the combinations working, like, suppose we can have all the combinations working in the way that -2 gets with 1, 3, 4, 1, 2, 1, -5, 4. So our first for loop will be at 0. That is our, let's talk about this one. So that is at like index 0, that's 5. And then we can have another for loop that can be int j. So now this int j can be equals to, I would say, I plus 1. I mean, yeah, makes sense. J less than nums dot length j is plus. So suppose I is at 0, so j is at like 1. Then it keeps on going. So yeah, now what we can do is we can have the sum. I mean, yeah, we can have the sum in respect with like I plus j. So we can add, suppose 5 plus 4, then 5, so that becomes 9, and then plus 1, I mean plus minus 1, that becomes 8. So we can have a variable int sum. We can call that as, we can have it as 0, initialize it as 0, and then what we can do is we can have sum plus equals, so sum equals sum plus uh, yeah, nums. Um, let's do one thing. Let's not start this with this, but let's keep it like out here. So it's like if I is 0, then j is at 0 as well. So yeah, it will have 5, then 4, then 1. So if I is at 1, then it's at 4. So it will add 4, and yeah, it makes sense that way. So it will be easy for us to have the summation. So yeah, sum equals to sum plus nums j, I would say. Yeah. So yeah, that's the sum. And now we need to compare it with something. So int max, this int max can be uh, integer dot, yeah, minimum value. Yeah. So this can be the minimum value. So if sum, so if a sum comes out to be greater than max, then our sum um, equals max equals sum. Max equals sum. And then we can return max. Is that gonna work? Okay. 17.6 phase 2 it works. I mean, honestly. There's some error right here. So for int I, that's 0, I less than nums not length, I plus plus for int j is that way. So sum equals nums j. Um, if sum is greater than max, so like for example, it's at I0, so it's at 5 at the moment. So now the j goes at 5, then it keeps proceeding. So now it's like 5 plus 4 minus 1, 7, 8, that gives 23, right? So yeah, sum becomes 23 for it. Yep. So now we come out of the loop, we see if sum is greater than max, it is 23 is greater than max. So yeah, 23 is greater than max. So max equals sum. So it becomes 23. Then we get again into the for loop, then we come at 4. Now 4 minus 1, 3, 7, 10, 18. It's sum greater than max. Yes, it is. Okay. Um, Maybe it's the placement of this if condition. Me, yeah, no, it's not the condition. It's returning, what's it returning for this? 78, the output is 78. Okay. What if let's, um, let's stay out 78. So I guess it's adding everybody. Yeah. What? 78 again. All right. So I guess that's the problem with this one. Sum equals num j. What if I do it I? Okay, it's 60. Um, Control X, Shift F. Yeah, 60. Okay. So let's stop messing around with the position of it's once. Okay. No, it's still 60. All right. So let's do one thing. Let's think about it. Let's keep it right here for the moment. Um, let's keep it Uh, J. Okay, so um, what do we have here? The thing is that I starts at 0 and then it proceeds further. And J is at I. Goes to nums of length J plus plus. So yeah, I mean I is able to handle for the I is able to decide which index you have to deal with, and J is able to add. Yeah, that's visible. So sum becomes sum equals sum plus nums J. Yeah, I guess what's happening is uh with at index 0 when it starts to traverse, it gets 23. At index 1, it's 4, 7, 10, 18. So it's 23, 18, 41. At minus 1, it's like 7, 8, it's 14. So 25, and then it's 7, it's like 7, 8, it's 15. So yeah, it's, so I get that. I get that why it's like it's adding everybody. It's like it's adding every iteration right here. So that's why every iteration happening is being added. So the error is identified. Um, so what can be done to solve this thing is that um, I mean we can see that if we got it, yeah. So yeah, what we can do is that we have integer max integer dot min value, so that's fine. Um, how to how wait, what if nah, but that won't work. Mhm. It's adding everybody with it, so sum equals sum plus num. So all right, in the first iteration we got 23. Now I need a new sum. All right, so what I can do is I can take this out. I need a new sum. That's it. Problem solved. I can have it right here, I would say. Yeah. Yeah. How about now? All right, cannot find that. Fair enough. Um, okay. How about now? Syntax error. Wo- Work for uh that case. Okay, it's not working for. All right, it's 5 and it expected 6. It's working for this part. Yeah. I guess it's working for one traversal, I guess now. I mean, no, I don't know. Let's see. Because here the maximum is going to be in the first traversal only, nowhere else. So that's why. Um, what can be done is the for this, I guess this works fine. The sum becomes 0 after every iteration. So yeah, that's fine. So it's like for int I, let's have sum 0. So for int j, uh, that's I. So it starts at -2. Let's talk about this case. It starts at -2 and then, yeah, it starts to add -2, 1, that becomes 1, -3, yeah, -2, that's -1, -3, -4, 0, -1, 2, that's 1. So 2, that's -3, that becomes +1. All right, so that becomes plus 1. So that all is now the sum. Sum is now plus 1. So if sum is greater than max, yeah, yeah, it is. So max is now sum. So max is now 1. So now again the sum becomes 0. But max is now 1. It starts this thing again. And then now max becomes something else, whatever the value we're going to get. Like if that's going to be greater than max. So yeah. Why is it not working? I mean, yeah. Where is the error in it? Let's see how many test cases this is satisfying. Okay, 92. Fine. Mm, where is it getting wrong? Expected is 6. Output is 5. Where is it getting the 6 thing? Subarray 4, 1 to 1. 4, 1 to 1. The output is 5. So you're saying that it's like 4, 1 to 1. Um, if 4, 1 to 1 has the largest sum 6, it stops at 1. Um, what if we put this in here? Yep. I figured that out because it's more like with my logic, the thing was that it's gonna keep going till the end. So if it's like if it's like at 4, so this will make sure that it doesn't stop at this one. It will make sure that it keeps going. Yeah. I don't know, and I don't want that. So yeah, I figured that out. I was able to look out for these two cases because it's more like I was able to figure out that yeah, it's gonna go till the complete array. That's the answer for this particular example. So complete array has to be traversed. So and the same for this case as well. So yeah, but this if condition inside the for loop, the second for loop makes sure that whenever I am traversing j, so it's more like if it's at 4, if my I is at 0, 1, 2, 3, if my I is at third index, yeah, my j is at 4 as well. So 4 minus 1, so sum equals sum plus nums j, sum is 0. Now sum is 4, sum greater than max. Yeah, max is the sum. Exactly. So now it comes again in the for loop only. So now minus 1 is minus 1 greater than, that now the sum becomes 3. Is 3 greater than max? Yeah, it is. So yeah, now my it becomes wait. Sum equals sum plus nums j. Sum becomes 4. Yeah, is sum greater than max? Yes, it is. All right, max is the sum now. So now max has become 4. Yeah, gets to 1 minus 3. Now sum becomes minus 3. Yeah, is minus 3 greater than max? It's no, no, it's not. I don't have an else thing. Wait. Um, hmm. Am I reading the code wrong? Because it's like the code works, that's the thing, but I need to understand like how what in J is I. There is no else condition, so I guess it's gonna go above. Now my sum is still 4. I mean, yeah, it goes to 2. It sees. No, no, it's not. It's 3. It goes to, it becomes 5. It goes to 1. It becomes 6. It goes to 5. Um, Wait. Josie, um, explain this code for, let's copy this strings. How is it getting the right answer? When I is 3, so J is 3, 4, max updated. So my accumulated max updated. And J4 is minus 1, 3. Max stays the same. At 5, it's 2, 5. Yeah, it becomes 6, it's 1, 6, 1, it's 5. So, okay, I understood. So that's my assumption was right. The max remains same. And yeah, it just has to check for the sum. So it found out its sum and that's it. But this code won't be working for all the cases. It's going to give time limit exceeded for big test cases like this. I mean, obviously, keeps on going and going. Yeah. So the codes like the test cases like these, we have Cardin's algorithm, if I'm saying that name right. So basically, in that, what we have to do is keeping it simple. Um, let's make the code up in that. So we'll have int sum as 0. Yeah. We'll have int uh, max as integer dot min value. Yeah. We'll have a for loop that's int I less than num dot length I plus plus. Yeah. Int I0 I not length I plus plus. So now what we will be doing is that we will be seeing that like if our sum becomes 0 or something. So it's more like in this type of algorithm, I have to make sure that the negatives are of no use to me. All right. So if my sum, so it's like sum equals uh, sum plus equals nums I. Yeah, that's it. That's fixed. Sum equals nums I. Yeah. So now I'll see that if my sum becomes less than 0, yeah, if my sum becomes less than 0, and then there is another condition, and if sum is greater than max, um, max equals sum, and then you just return max at the end. Yeah. So yeah. So this is the basic thing with this algorithm is that we need to make sure that if our sum is getting less than 0, it's of no use to us. All right. If our sum became less than 0, it's of no use to us because obviously, like negative values won't be giving me a greater sum. Yeah. So if my sum is less than 0, uh, my if my sum gets negative, my sum becomes 0. Right. Yeah. Let's try this. Okay. Yep. So the basic thing with this is that we just have to ignore the sum that's getting less than 0. And for this test case, sum plus nums I minus 2, is that less than 0? Yeah, my sum becomes 0. I don't need that minus 2. Is it 1? I get 1. Yeah, it's fine. Sum is greater than sum is greater than max, so now my max becomes 1. From this, it becomes 1. And my sum is like minus 3. I mean 1. Um, yeah. Now my last sum was 1, and now minus 3 has been added, so it becomes minus 2. It's sum less than 0. Yeah, remove that. Now it's 4. It's fine. 4 is nice. My max becomes 4 now. So now I have minus 1. It becomes 3. It's it's more than 0. It works for me. I'll see. Is sum greater than max? No, it's not. My max remains 4. Yeah. Now 2. Yeah, that's fine. I have a 5. So my max becomes 5. I have a 1. My max becomes 6. Yeah. Now I have a minus 5. Yeah. My sum becomes 1. It's still greater than 0, but it becomes 1. My max is now 1. Yeah. And then I have 4. It makes it 5. So my max is gonna be 6 because sum after 6 was never greater than max. That's the thing. Sum after I encountered 6 was never greater than 6. It was 1, it was 5, but it was never greater than 6. So that's why my max remains 6. And yeah, that's the output. We need to remember that we need to just give out the uh, integer, not the array. So yeah. So I guess now this is gonna work for every test case. All right, my bad. Expected was -1. Uh, if nums dot length equals 1, return um, about now. Um, wait, is it the same error? Oh, makes sense. Amazing. I mean, yeah. How do we handle these negative cases? How do we do that? How do we do that right? Yeah. How do we do that right? Um, sum is less than zero. Sum becomes zero. So that's what it is giving out. And if sum is greater than max, it becomes the max becomes my sum. How do I talk about the negatives? I mean, yeah, if sum is less than zero, make sum zero. But how can I talk about the negatives one? Because if sum is less than zero, that's minus two, it becomes zero. What if an array is completely filled with minus ones? What about it then? Because, yeah, then it will traverse till the array length, and answer will be minus one because that's the greatest. But yeah, it will traverse. So how do we figure that out? If sum is less than zero, yes, something to do with this. If sum is less than zero, I guess something to do with this. Sum becomes zero, or can't really figure out how to implement this thing in the same code. I mean, a new for loop. I mean, I don't know, but if or when I, I use I less than zero, less than zero, return if num I less than zero, uh, then the answer can be math dot max. Okay. It's now understanding. Yeah. Math dot max. Nums I comma max. Nums I comma max. That becomes so that becomes nums I less than zero, and that becomes what that becomes. I mean nums I it's zero. Nums I It's less than zero. So and the answer becomes maths.max. Uh, yeah, max. Why have a new variable when you have it? Some sort. Let's see. Hmm. Return comes I. Return maxi box. Unreachable statement, of course. It's after the return statement. So mm, okay, it works. Then by zero, num I is less than zero. Okay. Uh, now I guess I'll look up where is the error. Error here. Close to implementing an edge case bug. The bug. Yeah, exactly. If all are negative, then it won't work. We'll never be able to beyond zero. But the correct answer should be -1. Corrected code becomes. Wait, what? Important fix. Max C becomes not minimum value, but integer. Max minimums is ensures the correct result, even if all the elements are negative. But that resets to zero only if it's negative. Only if it goes negative, which helps in Subarray. Wait, so it's saying that we should have um, it as nums 0. I mean, if sum is less than 5 is less than 0, it's not. Here comes sum is less than max. It's not. I mean, it's not greater, it's equal to, I would say. But 5 is not greater than 5. It's also both 0 is 1 greater sum 0, max 5. I 0, 5, max 5, 5, 5. What? Yeah, correct. And you should be able to that's right. It's actually, I don't so make an update. Okay, it's not gonna be, it's gonna remain 5 only. Max is gonna remain 5. I guess, I get it. At 4, it's gonna just update the sum. The sum becomes 9. Is the sum greater than max? Yeah, max becomes 9. Okay, it works out. Oh, not bad. How? I mean, maxi is this. If sum is greater than maxi. Okay, let's put this. Wait, my bad. I mean, this was right. It's just this condition has to be above. Sum is greater than max c, so max c is equal to sum. So yeah, so this doesn't execute. For the negatives one, this has to be above. So that's it for the question. Yeah.